Hello, my students in grade 7. I hope you are all fine and doing good. This will be our lecture 1 in semester 2, the academic year 2020-2021. And as you can see in mathematics, of course, and as you can see, the title of our lesson is triangles. Triangles are very important and basic in mathematics. So please pay attention to this lecture and practice as much as you can in this lecture, because as much as you practice, things will become simple and easier for you. The objectives of our lesson: objective number 1, first I will define a triangle and recognize its elements. In a triangle we have sides, we have angles and vertices. Objective number 2, we will notice that the sum of angles in a triangle is 180 degrees. If we add the measure of the three angles in a triangle, we'll get the sum of 180 degrees always. Objective number 3, we will learn special kinds of triangles and their characteristics. Objective number 4, we will know how to calculate the measure of a missing angle in a triangle. Objective number 5, define and draw particular lines in a triangle. What is the height, how we draw a height, a median, a bisector, and a perpendicular bisector. Objective number 6, we will know the 3 ways of construction of a triangle, of course, according to a given. Definition and characteristics of a triangle. A triangle is a polygon. It is a geometrical shape that has 3 sides, 3 angles, and 3 vertices. As you can see in this figure, this red point is a vertex, this red point is a vertex, this red point is a vertex. So we have 3 vertices. We have 3 angles. This is an angle between 2 sides. This is an angle between 2 sides, and this is an angle between 2 sides. So we have 3 angles, and we have 3 sides. This is the first side, this is the second side, this is the third side. So in any triangle, we have these. We have 3 sides, we have 3 angles, and we have 3 vertices. These are the elements of a triangle or of any triangle. Now we have something very important. The sentence I'm gonna read now, please always remember this sentence and never forget it. This sentence is very, very important. It says, the sum of angles in a triangle is 180 degrees. We have seen that in any triangle, we have 3 angles. For example, we have a triangle ABC. The angles are BAC is the first angle, ACB is the second angle, CBA is the third angle. What do we mean by this sentence? This angle has a measure in degrees, this angle has a measure in degrees, and this angle has a measure in degrees. So if we add the measure of the first angle with the measure of the second angle with the measure of the third angle, our answer should always be 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C should always be 180 degrees. So please never forget this sentence again. The sum of angles in a triangle is always 180 degrees. Now I'll talk about special kinds of triangles. They are special because now I'll tell you everything about each of these triangles. The first triangle is the scalene triangle, so scalene triangle. The second is the right triangle. The third is the isosceles triangle. The fourth is the equilateral triangle. The fifth is the right isosceles triangle. And now I'll talk about each of these alone. The first kind of triangles is the scalene triangle. Which triangle do we call them scalene triangles? A scalene triangle, it is a normal triangle with no equal sides, no equal angles, and no right angle. So in a scalene triangle, we have no special thing, no special angle, no special side. For example, this triangle is scalene and this triangle is scalene. So please always remember that a scalene triangle is a normal triangle with nothing special. Triangle number 2 is the right triangle. Why is a right triangle called right triangle? Why is it special? Because it has one of its angles right. We have seen that in any triangle we have 3 angles. In a right triangle, there are still 3 angles, but one of them is a right angle which measures 90 degrees. So this triangle that we saw here, that we see here, is a right triangle since one of its angles is 90 degrees. And if we add this angle with this angle, both are 90 degrees, because in a triangle, all the angles are 180 degrees. Let's look at the second right triangle here. This is a right triangle, and this is the right angle. Always in a right triangle, the side opposite to the right angle. So this side is facing the right angle or opposite to the right angle. In a right triangle, we always call it a hypotenuse. So in a right triangle, the side opposite to the right angle is called a hypotenuse. And the two other sides in a right triangle are perpendicular to each other's. One is called a height, the other is called a base. But please always remember that the side opposite to the right angle is called a hypotenuse. So in a right triangle, the side opposite to the right angle is called the hypotenuse. The two other sides where the right angle is formed, they are perpendicular to each other's. Now, the isosceles triangle. In an isosceles triangle, it has 2 equal sides and 2 equal angles. So in any isosceles triangle, we have 2 equal sides. This side is equal to this side. So we put this mark and this mark, which means the sides are equal. And this angle is always equal to this angle in an isosceles triangle. In an isosceles triangle, we have a special vertex. In any triangle, we have 3 vertices. This is vertex 1, this is vertex 2, this is vertex 3. But why in an isosceles triangle we have a special vertex? Because from this special vertex, the 2 equal sides are issued or coming out. So from this special vertex, the 2 sides or the 2 equal sides are issued. And these 2 angles are equal to each other's. They are on the base. So the side opposite to the special vertex in an isosceles triangle, we call it a base. So all isosceles triangles have a special vertex. Why is it special? From where the equal sides are issued. And it has a special side called the base. It is opposite to the special vertex. And always the equal angles are on the base. That's why we call them the base angles. Let's look at triangle EDF. E is the special vertex since ED is equal to EF, and DF is the base since it is the side opposite to the special vertex. Angle EDF is equal to angle EFD. So this is the isosceles triangle. Now, number 4, the equilateral triangle. It has 3 equal sides and the 3 equal angles. So in any equilateral triangle, the 3 sides are equal and the 3 angles are equal. For example, if EF is equal to 4 centimeter, then EG will be 4 centimeter and FG will be 4 centimeter. Each angle in an equilateral triangle is equal to 60 degrees since they are all equal. So if we add 60 degrees plus 60 degrees plus 60 degrees, their sum will be 180 degrees. A triangle RTS is an equilateral triangle. The equal sides are RT is equal to RS is equal to TS. Please pay attention to these marks because they are very important. And I want to tell you that in any triangle, the scalene, the right, the isosceles, the equilateral, the right isosceles, we should know the definition of this triangle. This is the definition of these triangles. So whenever I tell you we have an isosceles triangle, directly we should say that this isosceles triangle has 2 equal sides and 2 equal angles. Whenever we say we have an equilateral triangle, the first thing we should remember is this equilateral triangle has 3 equal sides and 3 equal angles. Each angle measures 60 degrees. The final triangle is the right isosceles triangle. It is right because one of its angles is 90 degrees. Isosceles, it has 2 equal sides and 2 equal angles. So this will be the special vertex where the right angle is. These are the equal sides, as you can see the marks. Since this is 90 degrees, so the equal angles, each one of them in a right isosceles triangle will be 45 degrees. Now, we will learn how to calculate the measure of a missing angle in any triangle. To calculate the measure of the missing angle in any triangle, we should start from this very important sentence that I told you about before. The sum of angles in a triangle is 180 degrees. So always depend on this information to calculate the measure of a missing angle in any triangle. Suppose I gave you this triangle. It has 3 angles. The measure of this angle is A. This is the missing angle. We should know it. The measure of the second angle is 70 degrees. The measure of the third angle is 50 degrees. How should we start from this sentence, which is the sum of angles in a triangle is 180 degrees? We should say that A plus 70 degrees plus 50 degrees is equal to 180 degrees. This is the sum of angles in a triangle. So A is the missing angle plus 70 degrees plus 50 degrees is 120 degrees equal to 180 degrees. Now the unknown is A is equal to 180. When we take the plus 20 degrees to the other side, it becomes minus 120 degrees. So if I subtract 180 minus 120 degrees, I will get the measure of angle A, which is missing. It will be 60 degrees. Another example, given triangle ABC, we should find the measure of angle ACB. So we have angle BAC 120 degrees, angle ABC is 34 degrees. This is the missing angle. So we should start from the special sentence or from the sentence that I said before, which is the sum of angles in a triangle is 180 degrees. So if we add the measure of BAC angle plus ABC angle plus ACB angle, it will be 180 degrees. The sum of angles in a triangle is 180 degrees. Now we replace ABC, we replace it by its measure, which is 34 degrees. ACB is missing, we leave it as it is. Angle BAC is 120 degrees equal to 180 degrees. The missing angle is ACB. We add 34 plus 120, it is 154 equal to 180 degrees. So angle ACB is equal 180 minus 154, it is 26 degrees. So the missing angle will be 26 degrees. Another example, triangle ABC is right at A. What does this tell me? It is right at A. This means that the angle at vertex A is 90 degrees. What is the name of the angle at vertex A? It is CAB, or BAC should be equal to 90 degrees. So we should calculate the missing angle. So we say, since triangle ABC is right at A, this means directly angle BAC should be equal to 90 degrees. We start with the sum of angles in a triangle equal to 180 degrees. Now we replace each given angle, then we calculate the missing angle ACB is equal to 50 degrees. This writing is very important. Please, while watching this video and after watching the video, practice these exercises alone on draft to know how we write. Now, triangle MNP is isosceles of vertex M. What does this mean? If it is isosceles at vertex M, then the equal angles will be at vertex N and vertex P. So angle MNP will be equal to angle MPN. Since angle MNP is 40 degrees, then angle MPN is also 40 degrees. Again, please practice these exercises alone on draft. Now I'll talk about particular lines in a triangle and how can we draw these lines. The first line I will talk about is called, it has the 3 different names, but it is the same. We either call it a height or a perpendicular or an altitude. Please remember these 3 names. So heights, perpendiculars, or altitudes in a triangle. In any triangle, we can draw 3 heights. From each vertex, I can draw a height. Let us first define a height. The definitions are very important that you memorize. The height is a segment that is drawn from the vertex perpendicular to the opposite side. So from vertex A, I can draw a height to side BC. How? I use the set square, I put it on BC, passing through A, and I draw a perpendicular. This is the mark of the perpendicular that you should do after drawing a height. And from vertex B, I can draw a height to the opposite side AC. From vertex C, I can draw a height to the opposite side AB. As you can see, we can draw 3 heights from each vertex, and the 3 heights in any triangle intersect at the same point. This point is called the orthocenter. So the intersection of the 3 heights in a triangle, we call it an orthocenter. So again, to draw a height, we use a set square. In a triangle, the 3 heights are concurrent. Remember this word. Concurrent means they intersect at a same point, and the intersection of the 3 heights, we call it the orthocenter. Line number 2 is the median in a triangle. Let's define a median. The median is a segment from the vertex to the midpoint of the opposite side. So from each vertex, we can draw a median. But before we draw a median, we should find the midpoint of the opposite side. To find the midpoint of a segment, we divide the measure of the segment by 2. Suppose I want to draw the midpoint of BC. I measure BC using a long ruler. Suppose the measure of BC is 6 centimeters. So I divide 6 divided by 2, it is a 3 centimeters. So on the 3 centimeters using the long ruler, I assign the midpoint, which is M. So BM is equal to MC, since M is the midpoint of BC. After finding the midpoint of BC, I simply join it with A, then AM is called the median segment relative to BC. Also, I can draw the median segment from B to AC. I find B, the midpoint of AC, using the long ruler. Then I simply join P with B. Then BP is the median relative to AC. Also from C, I can draw a median to AB. I assign N the midpoint of AB using the long ruler. I measure AB and I divide the measure by 2 to find N. Then I use the long ruler to join N with C. As you can see, after drawing the three medians in a triangle, the three medians of a triangle are concurrent, which means they intersect at the same point. And the point of intersection of the three medians, we call it centroid or center of gravity. So the intersection of the three heights is the orthocenter. The intersection of the three medians is the centroid or the center of gravity. Now, how can we draw the bisectors in a triangle? Let's define a bisector. The bisector, we draw it for an angle. The bisector is a line that divides an angle into two equal angles. How many angles do we have in a triangle? 3. This is an angle, this is an angle, this is an angle. So we simply use the protractor. We measure the angle, this angle, for example. We put the protractor to find its measure. Suppose the measure of this angle is 40 degrees. I divide 40 by 2, it is 20. So I assign a point on the 20 and I join it with the opposite vertex to get the bisector. After drawing the three bisectors, they intersect at the same point, then they are concurrent, which means this point, the intersection of the three bisectors in a triangle, we call it the incenter. Number 4, perpendicular bisectors in a triangle. For whom do we draw the perpendicular bisector? For the side. How many sides do we have in a triangle? We have 3 sides. For side AB, we can draw a perpendicular bisector. For side AC, we can draw a perpendicular bisector. For side BC, we can draw a perpendicular bisector. How can we draw a perpendicular bisector? It's very easy. Suppose I want to draw the perpendicular bisector of AB. Using the long ruler, I measure AB. For example, its measure is 6 centimeters. I find the midpoint on the 3 centimeters, so this is the midpoint. I bring the set square, I put the set square at the midpoint, and I draw a perpendicular at the midpoint to get the perpendicular bisector. And the 3 perpendicular bisectors in a triangle are concurrent. But this point of intersection, that we call it circumcenter. So the intersection of the 3 perpendicular bisectors, we call it circumcenter. Why is it special? This point where the 3 perpendicular bisectors in a triangle meet or intersect is the center of the circle circumscribed about the triangle or drawn around a triangle ABC. So if we use the compass, we put the center here, we open the compass as A, and we draw the circle. Vertex A, vertex B, vertex C will be 3 vertices on the circle. Now, how can we construct a triangle? To construct a triangle, there are 3 cases. And in each case, we have a special given. According to the given, I choose the way of construction. Construction number 1, we will construct a triangle knowing the measure of 3 sides. So in this construction, I will give you the measure of the 3 sides in a triangle and you will construct. First, whenever you want to construct a triangle knowing the measure of 3 sides, we use a long ruler and a compass in this construction. How can we construct? These are the steps. First, we draw any of the three sides. We choose mainly the longest side. So I choose NL, which is the longest side, which is 8 centimeter. And we write its name. Using the long ruler, we draw the side NL, or any side. We draw side ML, for example. So I draw side ML, which is 6 centimeter, using the long ruler. Now I bring the compass, and on the long ruler, I open the compass 8 centimeter as an L. I put the center at L and I draw an arc. Also, I open the compass as the measure of MN, which is 7 centimeter. I put the center at M and I draw another arc. Where the two arcs intersect is the third vertex. I simply join this vertex with the other two vertices and I get the triangle. Please practice drawing this kind of triangles using the long ruler and the compass. It's very important. Now, how can we construct a triangle knowing the measure of two sides and one angle? So in the given, I gave you the measure of two sides and the measure of one angle. Here we use the long ruler and a protractor. First, we draw the first side. So first I draw side BC. Then on the vertex B, I assign the angle, which is 62 centimeter, and I draw BA, which is 4 centimeter, using the long ruler. Then I join to get the third side. Now the third one, knowing the measure of one side and two angles. So I know the measure of XY, angle X and angle Y. First, using the long ruler, I draw XY. Then, using the protractor, I assign the angle at X. Using the protractor, I assign the given angle at Y. Where the two sides of the assigned angles intersect is the third vertex. These three constructions are very important. Please practice drawing them and everything will be easier. Before I stop this recording, I want to remind you of memorizing the special triangles and the definitions of the lines in a triangle, which is the definition of the height, the definition of the median, the bisector, and the perpendicular bisector. And now I'm done, and I thank you all, my dear students.